Recording in progress.
Yeah, good evening, everyone. So, John, let's start off. Yeah. Hello, able to hear me, right? Perfect. So, let's start off. Let's start off with a question. So, last thing we are doing was this, the previous, the sigma e t power 4, TB power 4. Why am I feeling there is a lag? There is a slight lag, I guess. Let's see. So, let's do a weird question. We have a spaceship. In the form of a cone, right? Whose base is made of a hypothetical material. Which emits photons perpendicular to the surface. Okay. The curved surfaces do not emit any wavelength. So see, this is what happens. So we have a spaceship here where the photons are coming out like this. And because of this, right, it behaves like a rocket propulsion. Just like, gas is ejected backward and the rocket goes forward. This behaves like a rocket propulsion. So E is equal to 1 for the base, E is 0 for the curved surfaces. Let the mass be m. And temperature of this entire spaceship is T. And the entire outside is vacuum. Assume there is no gravity. So the temperature of the ship is maintained at T. Initially, the system is at rest. Find the velocity of the spaceship as function of time t. To give you a little more information, I'm sure you learned this in chemistry. Remember momentum of a photon? De Broglie wavelength. So momentum of a photon is given by h by lambda. I hope you remember that. If a photon has a wavelength lambda, it has a momentum h by lambda. So listen to the whole story here. Ali, Arjun, keep your cams on. So when the photons are coming out like this, isn't just like gas coming out? So when the photons are coming out, but this thing is massless. So even though photons have no mass, they have momentum. By Newton's third law, if the momentum is going this way, that will exert a force on the rocket in the forward direction, because of which the rocket will start getting a motion. So find the velocity of the rocket as function of time t. So basically, there is a concept called this thing. Actually, it is true. Huh? This is not some hypothetical thing. It's actually true. You can study more about it. This is called radiation pressure. It does exert force, but the problem is it is too small to detect normally. Anyone confused with the question, please ask. But what to do, think about it. I'll give you a minute or two. These are the kind of questions you'll get in advanced paragraphs. They'll give you something totally weird, and they'll expect you to read the paragraph, understand, and solve the questions. Did everyone got the logic here? The photons which are coming out from the back, they will act like a propulsion and they will push the rocket forward. Now, how do you use this radiation with this momentum of a photon to the rocket propulsion? Take 2 minutes, figure it out. Swastika, Vidyan, Udyan, cams on. This is a question, where it is difficult to figure out, but easy to solve. They actually understood what is happening. It's not much. So a solution will be like not many steps. Headache is the figuring out part. Help you? Start like this. Let there be n photons per second. Sigma t power 4 lambda by lambda is not given, right, Lakshika? There's no information about lambda in the question. So let number of photons emitted per second be equal to n. Okay. And momentum of each photon is h by lambda. Energy of each photon is hc by lambda. Fair enough. So what is energy emitted per second? Energy emitted per second is sigma a e t power 4. Now you need to understand all this energy is emitted in the form of photons. So whatever photons are coming out, that is only radiation, isn't it? Now, what is force? So number of photons per second into energy of each photon hc by lambda should be sigma a e t power 4. Make sense? Next thing, what is force? Force is change in momentum by time. Momentum per second, which is nothing but number of photons per second into h by lambda. Number of photons per second into momentum of each photon will give you total momentum per second. Multiply and divide by c. So nhc by lambda 1 by c. But what is nhc by lambda? Sigma a e t power 4 by c. What is force equal to? Mass into acceleration. What is acceleration? Sigma a e t power 4 by mc, which is constant. What is velocity? U plus at. U is 0. So sigma a e t power 4 by m into c is the speed of light into time. Check. Remember, n is something which you assumed. Lambda is something which you assumed. Nothing should come in the answer. Sigma, area is pi r square. E is equal to 1. C is the speed of light. I know everything. Please check. Again, what did I do? Assume there are n photons per second. Momentum of each photon is h by lambda. So force will be n into h by lambda. Multiply and divide by c. Then hc by lambda becomes energy per second. Energy per second is sigma a t per 4. From there, I got a force which is a constant force.
सर वो जो आपने फोर्स के dimensions लिए वो थोड़ी मैच कर रहे
Hmm.
h by lambda is
Momentum.
yeah
N is what? Number of photons per second. उसमें है ना time.
ठीक है
Clear with this? Did you observe something? Once you got the idea, the steps are not much, right? But when the first time when you read the question, you will feel like, what the hell? How can light move the rock? This thing. Observe, problem यही है. If you look at this value here, just observe there. Sigma in the numerator is 10 power minus 8. A is fine. Denominator में again 10 power 8 is there. So there is almost 10 power minus 16, right? That's a very, very, very small value. That is the reason in real life you don't see this. But actually radiation does push the surfaces. Clear? So someone is more interested about this, you can go and read about something called a solar sail. This is a concept actually in the NASA there. You know what's a sail, right? Normally they use wind for the ships to move. A solar sail, what they do, if sun is here, sun is emitting radiations. So the plan is, let's say you want to launch something out of the Earth and you want to send it to Pluto or something. Once the rocket goes out of the Earth, this will open up a big sails like this. The sun ka light will fall on this and this rocket can go automatically. Meaning it's a free of cost. You're using the sun ka radiation to make the vehicle go forward. It's called a solar cell.
No, they are not solar panels.
नहीं solar panels अलग है. Solar panels will absorb the energy and generate electricity, na. Here, तो preferably we prefer to use a mirror reflecting thing, so that bouncing to will get more momentum.
Okay.
Clear with this? Everyone got the idea here? Neil, Anusha, clear, na? Vartika, Yasha, clear? Perfect. Next one. So this is a little weird one, but it's a good one. Let's say we have a spaceship. Is maintained at 500 Kelvin due to its internal operations. Meaning you have a spaceship there. So the temperature of the spaceship is 500 Kelvin, meaning inside you have engine room, facilities and everything. Na? So whatever heat is being produced, that is maintaining the temperature of the spaceship as 500 Kelvin. Outside is vacuum and the temperature of the spaceship is 500 Kelvin. So now what you did, now the spaceship is enclosed by a hollow shell of radius 2r. इसका radius is r. ठीक है? Assume E is equal to 1 for, assume all surfaces are black. E is equal to 1 for all surfaces. What do you mean by internal operations? Indirectly, he's saying inside there is a heater which is producing heat, right? That is maintaining the temperature of the spaceship. Fair enough? Now what you did, the same spaceship, you covered this whole thing with a shell of radius 2r. This radius is r. Now remember, this spaceship is still producing the same amount of power which it was producing before. Just because you covered with a shell, why will the spaceship power change, isn't it? Now find the temperature of the spaceship and the shell. Find temperature of the spaceship and the shell. Just to give you a little idea, think of like this. Let's say you're sleeping, it's pretty cold. Your body maintains your temperature. Now, if you put a blanket on top of you, will you get hotter inside or will it become more cold inside? It will become more warm, right? So, exactly क्या हो रहा है ना? See, listen once. You have a spaceship. So inside there is a heat being generated. That heat escapes from the surface. ठीक है? In that scenario, outside ka temperature is 500 Kelvin, surface ka. Now what you did, you took the spaceship, you covered with a blanket here. So heat is being still radiated, but this heat will go here, and this spaceship also will, the shell will give heat outside, and some of the heat will go inside also. Means some of the energy comes back to the spaceship, isn't it? Because of which the spaceship ka temperature will increase. It feels more warmer inside. तो spaceship का temperature change हो जाएगा equilibrium में. So find the temperature of the spaceship and the shell. I know the question can be quite confusing, but yeah, but this is a kind of a question. I think Jay may did ask a question, but that's a much easier one. The question was this: we have a spaceship at 500 Kelvin. A shell of almost same radius is placed on top of it. Same radius ka thin difference ka shell is placed on top of it. Find the new temperature. That was a question. I changed it. This is a much better one. So initially the spaceship is generating some heat. That's why temperature is 500, or else the temperature would go to 0 Kelvin. The spaceship will completely freeze. Matlab spaceship is producing some constant power. How much we don't know. Now on that spaceship, you cover this with a shell of radius 2r. Now something will happen and they will get new temperatures. Find the new temperature of the spaceship and the new temperature of the shell. Try. You got 3 minutes. Think about it. This would be a proper advanced question again. So all these questions we are doing today will be all advanced only. Even the last one that we did was also good, pretty good question. If you remember this one, heat transfer between plates. But anyone still confused with the question, please ask. I am pretty sure question clarity should be there. If you didn't understand the question, it is my fault. Don't know how to do, that's fine. Keep thinking. Any ideas? Temperature of the shell will be easy, right? If I ask you this, I'll ask you this as a paragraph or more than one choice question. See, first thing, before covering with the shell, someone got 866. इतना अच्छा number आया रे? I don't know. Shell का temperature नहीं Aryan, it should be less than 500. This is before. So we have the spaceship. Let's say the spaceship is generating some power P. So this same power is radiating out. So this power P should be equal to sigma AE 500 power 4. Agreed? Power generated by the spaceship should be equal to the power emitted by the spaceship. Steady state, na? Agreed? Power produced by ship should be equal to power emitted. Whatever you're producing inside, everything should escape through the surface. How it's clear with that? You're looking very suspiciously on that. Clear, na? Now, after covering with a shell, now tell me one thing. The spaceship will still continue to produce same power. Agreed? Spaceship doesn't care what is happening outside. It will continue to produce same power. Now you tell me, in steady state, power emitted by the shell Shouldn't this also be power P only? Power escaping from the shell should also be P. Why? Steady state. Whatever you're producing should go out, or else temperatures will keep changing. Does everyone agree with that statement? I don't know what is happening inside. I don't care. But whatever is produced here, everything should have gone outside to infinity. If inflow is not equal to outflow, temperature of the system will keep on increasing. But you said it is in steady state. So eventually temperature should become constant everywhere. This is 2R. Meaning the power emitted P from the shell is sigma. Area will be 4 pi 2R whole square E T shell power 4. And here P is nothing but sigma 4 pi R square E 500 power 4. So power of the shell is nothing but P only. So sigma 4 pi R square E 500 power 4 is sigma 4 pi 4 R square E T shell power 4. Everything will cancel. You end up with T shell is equal to 500 by root 2. Check it out. This is the temperature of the outer shell. Is this statement making sense? Whatever power the spaceship produces, that should be escaping the outermost shell. If inflow is not equal to outflow, the system is not in steady state, the temperatures won't be constant. Clear till here?
The question you never mind. समझ
What did you do? You did something weird. Now what to do? Copy. अभी तो क्वेश्चन नहीं हुआ. The main question is find the temperature of the spaceship. ये तो outer shell का temperature निकाला हमने. That would be an interesting thing. Any doubts on this page, please ask me. You just have to think in terms of steady state. Then you'll understand heat is coming, heat is going. But think about it, logically. If I give you this spaceship and covering, can you see what is inside? You can't see what is inside. What you will simply see is heat is going out from the surface. And that is nothing but the heat produced by the spaceship inside. Fair enough? All clear with this page? Turn in the page. Now listen to this thing. Here, this is important. Now let's take this energy flow diagram for this ship. Let the temperature of the shell be T. Spaceship be T. T dash. T dash is the temperature of spaceship. Temperature of the shell is T shell. Now see what is happening here. From inside, you are getting power P. Okay. From inside, you are getting power P. And how much are you getting from the shell? How much are you getting from the shell?
P मिल रहा है.
No, you're not getting P. You're getting something else. Now, this is an important concept. See, this is what makes this question very good. Whenever you take a surface and if you put an inner shell, let's say this is small r and this is capital R. Listen to this thing. So whatever radiation is emitted here, this will fall on this. This will fall on this. This will fall on itself again. Why will all the radiation emitted will go and fall on the center? The radiation emitted in all directions, right? So some of the radiation goes and falls on the own shell, own shell. Are you getting this? All the radiation that is emitted by the outer shell will not go and fall on the inner shell. Is that making sense? So power emitted by outer shell will spread over in all directions. So power received by the inner shell is given by power by outer shell into surface area. It will be proportional to the surface area. Surface area of inner shell by surface area of outer shell. So in our scenario here, the power received by the inner shell, this power received by this shell into 4 pi r square by 4 pi 2r whole square, which is p by 4. Are you getting this? So whatever power the outer shell is emitting, you get only 1/4 of the power of the shell. Is that making sense, everyone? All the radiation emitted by the outer shell will not go and fall on the inner shell because the photons are emitted in all directions. Anyone confused with this statement?
सर जो original question था जिसमें negligible, I mean,
हाँ,
almost
original question में क्या था ना? They said there is a shell and they said it is covered by a sheet of almost same radius.
तो पूरा उस पे
So हाँ, everything will fall ना. So then ये problem ही नहीं आएगा. You don't need this statement.
okay.
So smartly ना, they avoided this statement by saying that it is covered by a shell of almost same radius. In that case, surfaces here will be same, right? Both of them. Are you getting the question? The actual JEE question was that you covered it with a shell of same radius, almost same radius. So then this problem won't be there. And now what happens here? This shell is also emitting its own radiation here, which is sigma AE T dash power 4. So power received by spaceship should be equal to power emitted by spaceship. Now remember, spaceship is getting power from two things, huh? And one more thing, power is not a vector quantity, huh? So don't say vector quantities cancel ho jayega. This is energy coming inside. So you are getting power P plus power due to the shell by 4. This is coming due to internal operations. This is the heat produced by the spaceship inside. This is coming from the outer shell. This is nothing but sigma AE T dash power 4. So this is P. And what is power of the shell? Just now we wrote this. Power of the shell is nothing but P only. So this is P by 4, which is sigma AE T dash power 4. So this is 5 by 4 sigma AE 500 to the power of 4 by sigma AE T dash power 4. Therefore, T dash will be 5 by 4 to the power of 1 by 4 into 500 Kelvin. Please check. If you see, right, it is mostly the statements. Aisa hoga, so that's why it happens like this. This happens, that's why this happens like this. It is like that. Question can be confusing. So please have a look at this. Listen to the whole thing, what I did, I'll explain you again. So initially what is happening? The spaceship is producing some power from inside. So that because of that, the entire spaceship is heated to 500 Kelvin. And whenever the surface has some temperature, it will emit heat. So the heat emitted is sigma AE 500 power 4, which is equal to P, where P is the power emitted by the heater. Now, when you went and covered this with a shell, whatever power you're producing from inside has to escape to infinity. Agreed? Because inflow is equal to outflow, steady state. If inflow is not equal to outflow, temperature of the shell will keep on increasing till the emission becomes more. So eventually you reach the steady state, means inflow is equal to outflow. Now I don't care what is happening inside, but one thing I'm sure, whatever power the spaceship is producing is escaping out. And the only way you can escape out is through radiation from the outermost surface. Agreed? The only way you can escape to infinity is from radiation through outermost surface, which is sigma AE T shell power 4. Area is 4 pi 2r whole square. That should be equal to power P. Power P is this. I equated, I got shell cut temperature. Any doubts on this switch? Clear? So shell is the most easiest one to get. Then whatever, now what is happening, this spaceship, after covering, you're getting energy from two places. One, you're getting from inside. Second, the outer shell. Now remember, the outer shell, right, when it is emitting radiation, it is emitting outside also, it is emitting inside also, na? When you write sigma AE T power 4, it is emitted on both the directions. So the one which is going out, that will go to infinity. I'm okay with that. But the one which is going inside, everything will not fall on the inner shell. Some of it will fall on its own self. I hope you're getting that. And that ratio will depend on the surface area. So power received by the inner shell due to the outer shell will be in the ratio of the surface areas. In that case, it is P by 4. So you are getting P from inside and P by 4 from the outer shell. That should be equal to your own emission. Again, why? The spaceship is in steady state. Since the temperature of the spaceship is constant, whatever you're getting should be equal to whatever you're leaving. Equations and you're done. Please check. Ask me if you're confused. Any step you're not clear, confused. Why neglects what's happening in the first part? I didn't understand what you're saying. What did we neglect, Anusha?
Sir, in this we have like counted the power like which is emitted by the shell also, but in the first part we just did the power which is due to its internal operations.
ये सी अभी वही बोल रहा हूँ ना, यहाँ पे जो भी होगा ये इन दोनों का बीच में है. You just see like this thing. I don't care what is happening inside. ठीक है? Now if I ask you this question, पूरा system में what is the total power? Who is generating the power in this total system?
The
spaceship.
and
And how much is it producing? No, who is producing it? I'm not saying who is reflecting and who is absorbing. Who is producing it? Who is the source? Only the spaceship. How much are you producing? P. Now this total power P should go to infinity. And the only way you can go to infinity is from the outer surface. Now inside whatever is happening, I don't know, but the total energy that is going out should be equal to the total power that you're producing. Getting this?
Yeah.
You understood my statement, na? Let me tell you what is exactly happening. If you want in terms of numbers, let me show you that. Listen everyone, what is happening. From inside, you're producing power P. Okay? Now, just now we proved, see, how much are you reflecting? 5P power 4, no? This spaceship from on the surface is giving 5P power 4. Look at the irony. I'm producing P, but you're giving 5P by 4. Okay? How is that possible? Because this guy is giving P by 4 to this. Make sense? Now, abhi ye 5P power 4 will go and fall on this shell. So this guy is receiving 5P power 4 plus यहाँ पे जो भी reflect हुआ बाकी 3P by 4 will come from its own self. So totally, how much did you receive? 5P by 4 and 3P by 4. So I received 2P. So I will send 1P to space and 1P again inside. समझ में आ रहा है कैसा हुआ distribution? The heat is playing inside only with whatever it is. But end of the day, the story is whatever I produced is going out. I hope this made sense. You're getting it? It is like, you know, when you and your sister are sitting and there are some 10 chocolates and you have to distribute. Isn't that how you distribute? 1 chocolate for you, 1 chocolate for your sister, 2 chocolates for you, 3 chocolates for your sister, 4 chocolates for you, 1, 2, 3, 4. Then you say, you take this, I will take this, you give this, I will have this, that, this. End में you'll give 3 chocolates to your sister, you take 7. And you say this is equal. Something like that will happen. So internally, lot of nonsense is happening. But you just need to see one thing, whatever you produce is emitting out. Clear? I hope this was clear. Now, you want to practice this for fun. What you can do? Let's say this is covered by 2 shells. 2R and 3R. You try that later on for fun and you see. Now, this will be a big messed up thing. There'll be a lot of emissions between them, but it is fine. Clear? Next one. We have a solid sphere with a cavity. In the middle, we have a heater. It's a point heater which is emitting heat. In negligible dimensions. So this heat will go and fall on the inner surface. And then what will happen? After falling here, the heat will flow from here to here, the inside surface to outer surface, through conduction. And here, this is radiation. Are you getting it? So the energy will go from the heater to the inner surface through radiation. After reaching there, it will flow through conduction. The inner radius is R, outer radius is 2R. E is equal to 1 for all surfaces. Outside is vacuum. Find temperature of the outer surface and inner surface.
सर के चाहिए होगा
K चाहिए तुझे. K is K. So I combined a radiation with conduction. This is a solid sphere with cavity, or you can say hollow shell with thickness. Both are same. And look, what will happen from here? After conduction till here, what will happen? Again, photons will go out now from here. Again, radiation. समझ में आ रहा है टोटल प्रोसेस क्या हो रहा है? So from the heater to the inner shell, radiation. Inner shell to outer shell, conduction. Outer shell to infinity, radiation. System is in steady state. Find the temperature of the outer and the inner surface in steady state. This is a good one. A better question would be find the temperature as function of x, where x is the distance from the center. But fine, let's find inner and outer. If you know that, we can take care of it. This one. There is. Now see, you thus what you said now, that same statement is what? Power inflow is outflow, no? That has nothing to do with whether it is a spaceship or a shell or anything, isn't it? That's a steady state condition. So that you can always validate. Temperature of the outer shell is the easiest one. Again, why logic hai? Whatever the heater produces should be emitting from the outer surface. Inner surface is a good one.
फिर इनर सरफेस का चेंज क्यों होगा? वो कंडक्शन से जा रहा है तो अंदर
तो बिना टेम्परेचर फ्लो क्यों होगा गॉड? बोलो, कंडक्शन से जा रहे हैं, सो शुडंट देयर बी टेम्परेचर डिफरेंस बिटवीन इनर एंड आउटर सरफेस?
या
अगर इनर आउटर का टेम्परेचर सेम है तो हीट फ्लो क्यों करेगा?
नो दैट इज ओके। ठीक है सर, आई विल सॉल्व एंड
These are the kind of questions, which radiation people find tough. Conduction is actually, people are fine with conduction, but when it comes to radiation, these questions mess it up. ये सब होगा एडवांस का पैराग्राफ क्वेश्चंस. I hope everyone got the outer surface का temperature. That's the easiest one. T outer is fourth root of power by sigma A. Yeah, वही है basically. Power emitted should be equal to sigma. Area is 4 pi 2r whole square E T power 4. एक स्टेप में आ जाएगा वो आंसर. इनर सरफेस का टेम्परेचर See. Now, whatever power you're producing, P, this also should be P. And whatever you're radiating, let it be. So whatever power is coming from here through radiation, P, should be equal to, this is also P. And again, radiation, this is also P. That means power produced by heater is equal to the conduction heat or conduction current. This is also equal to the power radiated by the outer surface. Therefore, P is equal to power by the outer surface is sigma, area is 4 pi 2r whole square E T 2 power 4. So let this temperature of the outer shell be T2. Let this temperature of the shell be T1. तो यहाँ से you'll get T2 का value. Next thing from conduction.
इसी फॉर्मूले से why can't we get पहले T1 का वैल्यू and then T2 का वैल्यू थ्रू कंडक्शन?
अभी T1 का कैसा करेंगे? T1 का how will you get? Whatever heat is falling in here, that is becoming conduction, na? There is no radiation between these two. You are saying you'll write P is equal to sigma E T1 power 4?
And then conduct करके T2.
No, God. There is a solid conductor here. Where are the photons here?
Okay.
Photons are coming and falling on in T1. They're getting absorbed and that heat is going through conduction, na?
Oh, makes sense. हाँ.
ना बाहर कुछ vacuum, empty space, air, तो you will send photons. Now this guy will be how much then? So dq by dt is what? Dq by dt is nothing but temperature difference by thermal resistance. So here temperature difference is T1 minus T2 by R thermal, and dq by dt is nothing but power. So P is equal to T1 minus T2 by R thermal. So from here I get T1 is T2 plus power into thermal resistance. How to find R thermal resistance? We have done this in conduction. At a distance x, take a thin shell of thickness dx. All these thin shells are in series. So D resistance will be length dx by k 4 pi x square. Therefore, R thermal is 1 by 4 pi k integral dx by x square from R to 2R. That would be 1 by 8 pi k. Do you remember this? We have done this in conduction. And then done, you substitute here to get the answer. Therefore, temperature T1 will be T2 plus power. This is 1 by 8 pi k. There, we combined conduction with radiation like this. In case you forgot, that problem we have done it, this problem. Hollow shell of radius r and 2 or find R thermal. That was the first part of the question.
Sir, there will be an R also, right?
Which one?
8 k pi k R.
R भी रहेगा ना. Thick. Got this? Anyone confused with this, please ask me. You should definitely try all the problems we did today. But did you observe one thing? End of the day, what did I do? Is one equation, two equations, isn't it? If you see the problem, the number of steps are less in all these problems that I did. But getting an idea like, boss, aisa ho raha hai, that's why I'll do like this. That becomes the most important thing. Huh, Monica, clear with that? Do adjust your camera a bit. I can't see you. Vidyut, there. Be there. Don't lean back. You're doing yoga stretches, which is good for health, but still. Clear? Going ahead. Next one, Ali. Clear, na? Abhinav? Arjun?
Yes, sir.
Great. Let's find the temperature of the sun surface. Ever thought about it? You must have studied in school. Temperature of the sun surface is around 6000 Kelvin. Who went there? Someone went with a thermometer and measured it. Where are you? Heat transfer. So this thing, right, is called, there is something called solar constant. The solar constant is given by S, which is nothing but the amount of radiation, the amount of energy received by Earth's surface from sun per second per unit area. So here they give you the value, see. So here S ka value is 8.2 joule per minute per centimeter square. Means if you go out in the sun and if you put a 1 centimeter square ka sheet, in a minute you'll collect 8.2 joules. So indirectly, solar constant is nothing but intensity. This is intensity of sun on Earth's surface. If you remember, intensity is nothing but power by power, which is energy by time, by area where this energy falls. So this information we have. So from the Earth's surface, you know the solar constant, and the angle subtended by the sun on the Earth is 0.53, meaning he's giving you this. This is sun. Earth is somewhere here. So when you measure this angle now from the diameter, this angle is theta. And he's saying this angle is 0.53 degrees. So you know the angle, you know the solar constant. Itra information hai. From there, you have to find the temperature of the sun. Calculate the surface temperature of the sun. How do we do this? Now, how is this theta useful? How is that S useful? Now you figure out. We can find the temperature of the sun with this data. The answer comes pretty close. We need SA of the sun. Who is SA? Surface area. You don't need. Who will go and measure the surface area of the sun? Question तो वही है ना. You can't. अगर sun तक ही जा सकते हैं तो we could have done something. Maybe only Lord Hanuman knows. Remember Lord Hanuman went and ate the sun. That was the story there. So he is the only person you might go and ask. So I तो don't know the surface area of the sun. We can take the Earth radius 6,000. नहीं चाहिए उत्साह. You know, today's all the questions, right, are easy to solve, but ideas, you know, you don't get ideas what the hell is happening. See, let's start like this. Let the temperature of the sun be T. So let the sun ka temperature be T. So whatever radiation the sun is emitting, the power emitted by the sun is sigma area T power 4. Agreed. Now somewhere very far off, we have a insignificant Earth, right? So from the center to here, let this distance be R. So meaning Earth is lying on assuming it is almost a circular path. This distance is r. Okay. Now, what is intensity? So intensity on Earth is nothing but power due to the sun by 4 pi r square. Do you agree? The total power emitted by the sun by the total surface area 4 pi r square, isn't it? Because the energy from the sun is going in three-dimensional sphere, and Earth is there somewhere on at a distance small r. So all this power P is spread over a surface area of 4 pi small r square. So power of the sun here is sigma, area is 4 pi capital R square, E is 1, almost sun is a black body, T sun power 4 by 4 pi small r square. Intensity on the earth is nothing but solar constant. So solar constant is sigma r by small r whole square into T sun power 4. Now from this, you can clearly see this is radius r. This angle is theta by 2. We get tan theta by 2 is r by small r. For small angles, this is theta by 2. Small r is pretty large compared to the radius of the sun. The small r is almost 15 crore kilometers. Radius of the sun, I think, is around million, I guess. So it's still small. So this angle is theta by 2 and this angle is theta by 2. Now, I don't know capital R, I don't know small r, but I know what is capital R by R. So S is equal to sigma theta square by 4 temperature of the sun power 4. Therefore, temperature of the sun is 4 times solar constant by sigma theta square. Theta should be in radians. I think when you solve this, approximately you end up with 5800 Kelvin, which is pretty close. Got this? So what you want is not capital R and small r. What you want is a capital R by small r ka ratio. They both go off. That's where the angle matters there. An angle you can measure. Ever seen on the roads? There are people, sometimes they stand with a machine and they're looking through that. Civil engineering construction, they actually measure angles with that equipment. So getting an angle is possible. Do have a look at this.
Sir,
Hmm.
if we taking solar constant in joules per second or joules per minute will matter.
Second में ऐसे यूनिट में कन्वर्ट करना सब.
Okay.
सब ऐसे यूनिट में होना चाहिए, but here they gave you in joule per minute. All clear with this? Now in radiation, another part is Wien's displacement law. Going ahead, any doubts on this page, please ask me. Perfect. So what Wien's displacement law says is, now we keep on saying, body emits radiation, great. So, but what about the wavelengths? When a body emits radiation, it emits photons of all wavelengths. Now, among this, a certain wavelength lambda m contributes maximum energy. So what the means displacement law says is the product of lambda m and temperature of the body is constant. This is the wavelength which contributes max energy. So technically, this is also called as E lambda, spectral energy density, if you remember this word. Energy emitted at a given wavelength. T is the temperature of the surface. This constant, right? For black bodies, the constant ka value is 2.88 into 10 power minus 3 meter Kelvin. Let's see what it means exactly. So what thing is telling you, right? If the temperature of the body is high, then the wavelength emitted will be least. Means as the temperature of the body becomes higher and higher, you start emitting higher energetic photons. So if I try to plot a graph, this is what you'll observe. So if you plot a graph between E lambda versus lambda. So E lambda is the energy at a given wavelength. Energy per unit time. I'll give an analogy that will make you understand better, but let's see technically what it is first. Again, a bell curve. So there's a particular wavelength lambda m which contributes maximum energy E peak at a particular temperature T. So what does this exactly mean? Think of like this. Let's say you have some money with you, okay? But you have money in different denominations, right? And you have different number of coins. And this is the money that you have. So let's say you have 1 rupee coins, 1,000. How much money you will have then? 1,000 rupees. Let's say you have 2 rupee coins, 2,000. Then you'll have 4,000 rupees, 4K. Let's say you have 5 rupee coins, 5,000. Then you'll have 25K. Let's say you have 10 rupee coins, 2,000. You'll have 20K rupees. And let's say you have 20 rupee notes, 1,000. Let's say 500. Again 10K. Now the total money that you have, each denomination is contributing different amount of money. Now, can you tell me in this which denomination is giving you maximum amount of money? The 5 rupee, right? So in this analogy, denomination is like wavelength, number of coins is like number of photons, money is like E lambda. समझ में आ रहा है? So you are getting wavelengths of different wavelengths, but in that one wavelength is contributing maximum energy. So you have money in different denominations: 1 rupee coin, 2 rupee coin, 5 rupee coin, 10 rupees coin, 20 rupees coins. But the 5 rupee coins contribute the maximum amount of energy. So this 25,000 will be E peak. Are you able to get this? Getting it? So here, 5 rupees contributes maximum amount of money. So this is your E lambda. This is your lambda m. Is that making sense? Now, what about this graph then? What is the area under this graph? So if you take integral E lambda d lambda from lambda 1 to lambda 2, this gives you energy of all the photons between wavelengths lambda 1 and lambda 2. So basically area under the graph E lambda d lambda from 0 to infinity will give you just try to understand the meaning of mathematically. 0 to lambda matlab the energy of all the photons emitted is what? Total energy per second. which is nothing but sigma A E T power 4. This is area under the curve. In our example, if you take this entire money here, the total money is similar to sigma A E T power 4. Does it make sense? If you add the energy due to all the photons, what do you get? You get total energy emitted per second. So if you add all this money, you get sigma A T power 4. Are you guys able to understand the analogy here? So this is the story. Like you have money, so you are giving energy, but you are giving energy in different photons. 10 angstrom ka photon, 20 angstrom photon, 30 angstrom, 100, 200, 300, so on. So each photon is contributing different amount of energies. So if you look at the graph here, there are very few photons with very high energy. See, less lambda matlab high energy. You will find more and more photons in the middle, Gaussian distribution or the bell curve. And then again, you have very few photons with very high wavelength. So in the center, you get a peak value. And that wavelength into temperature is constant, but that is experimentally derived. So you can, this using an analogy, I am saying you have money with you, 1 rupee, 2 rupee, 5 and 10 and 20 rupee, but 5 rupee contributes the maximum amount of money. So that lambda m into temperature is constant. Is the explanation clear, everyone? So now you tell me, if I increase the temperature of the body, then lambda should be less. So if I heat a body, what is the first color you will see?
Red.
Red.
Red. So exam question aisa hoga. There is a body which is continuously heated. What is the first color you will see? Initially, you will see nothing. Why? Because it is emitting infrared. Lambda into T is constant. Na? If temperature is less, lambda is more. It will be in infrared. You can't see. If temperature increases, then what will you see?
Red.
Red के बाद क्या? Red. उसके बाद क्या देखोगे? If temperature still increases?
Or
Orange.
orange, yellow,
Orange, yellowish. Still, if you increase?
green.
Blue.
Green नहीं दिखेगा. You will see white. Think na, if all
Blue
colors
also
are
is visible.
emitted, no. If all colors are emitted, what do you get? White.
सिर्फ वो green
ना?
दिखेंगे.
नहीं. अरे जब green आएगा, red भी आ रहा है ना. It is not like only green is coming out. बाकी wavelengths भी है.
Makes sense.
Are you getting the point? It is not like red आने के बाद red बंद हो जाएगा and सिर्फ green आएगा. Remaining wavelengths are also coming. Are you getting it? So red, green, all those colors mix up. So what you get? White. If you still increase,
But blue is visible.
Blue is visible, right?
अरे but blue will get mixed up with red ना. God.
But why bright stars there are blue?
तो वही सुनो ना. If you still heat, what will happen? You will see white. If you still heat, then you will see blue. Why?
It might be ultraviolet.
If you keep on heating more and more, क्या होगा? The range will go more into ultraviolet region. So red will stop vanishing, na? Red will become very less. But ultraviolet you can't see. So what you will see is only blue. So color का transition ऐसा होगा. First you'll start with red, yellow, orange, and then you'll get white, and then you'll get a blue. Here I don't have that, but I'll show you something. This is how the colors look. This is 1400. This is almost infrared. You can't see. 1400 पे reddish, then orange, yellow, then white. Now, if you continue to heat further, metal में you can't see. The best example, na, you can go and check out your stove. When you switch on the stove, what is the first color you see? First, you'll see blue because it's a hotter flame. Once the flame goes little higher, it cools down, na? Flame becomes yellow. If you go and just switch on your gas stove, you'll observe. First, you'll see a blue flame. So blue flame is actually much hotter than white flame. So let me have it.
So, So,
Oh God.
so is that the reason why the sun is seen red in the morning and then as we progress?
Oh, that is
Right.
more of a dispersion with the atmosphere. Atmosphere का problem है वो.
Okay.
It has nothing with the sun as such.
more light at every wavelength. At red with fast, if it's by will take turns.
So see, so this lady has a bulb. So what we're doing is we're sending current. More current you send, the more gets it heated up. So more temperature.
Just a little bit, so that there's a little bit of current running through the light bulb, and we'll see that it lights
So if you see the little current going, you can't see anything. It's not hot.
up, and we'll take a look at the color. So
There, you
here
can
the
see.
light bulb is barely lit, and you can see that it's red-orange. It's a very reddish color. This is almost exactly the color of Betelgeuse, one of the stars in the night sky. If I add more current so that the filament gets hotter and hotter and hotter, you can see that the red goes away and the color becomes dominated by yellow. If I continue on and I go past that point and I keep heating up the filament hotter and hotter and hotter, you can see it gets much, much brighter as it gets hotter, but then it also turns bluer as it gets hotter until
It becomes white. Now this bulb does not has capability for so much current, the device. So वो भी देखेंगे. Did you see what happened? It became white because it is emitting all
Here,
wavelengths.
this is as high as I can go with this particular light bulb, and you can see
There.
that the color
This is how it looks. If you keep increasing more and more, white will start vanishing. That is because, see, what is white? White is nothing but all 7 colors, isn't it? So if red starts vanishing, if green, all the colors start vanishing, what you'll be left out is ultraviolet and blue. In reality, this bulb currently, which you're seeing blue, right, is actually very bright. It's emitting a lot of radiation, but you can't see. Are you getting it? Most of it, the light it is emitting is ultraviolet. You can't see, but the room is actually very bright. That is the thing. It is not in your visible region. But right now, if they ask you a bulb which is blue and a red bulb, white bulb, right? White is looks more bright to you, but the blue bulb is more intensity.
of the light bulb is definitely bluish, and it's extremely bright at this high temperature. So this is something that you should look for when you look at stars in the night sky. You should look up into the night sky and see that some stars are reddish, like Betelgeuse is reddish, and some stars are bluish, like Rigel, also in the constellation Orion. Stars are red or they're blue because they're different temperatures. So cooler stars around 2000 degrees Kelvin are redder, or hotter stars around 10,000 degrees Kelvin or even hotter than that are bluer. And sometimes they emit even into the ultraviolet or into the X-ray when they're very, very hot. This might be a little bit confusing to you, that hotter things are bluer and cooler things are redder. And that's because you're used to plumbing. In plumbing, what the plumbers do is they use blue for the cold tap.
The problem क्या होता है ना real life में, if you see hot water we represent with red and cold water we represent with blue. That's where the confusion comes, like blue should be cold. There is another one. I think I did show you everything, I guess. Yeah, I did show you that. Clear with this? So the color transition goes like this. So if an object is heated, the transition will go from red, then it goes to orange, yellow, then it becomes white, and then comes blue. Okay? So white is nothing but combination of all colors. The reason you're getting blue is because you're producing too much ultraviolet. The visible colors are missing, so it looks more bluish. Clear with this? Now for this graph here, so examiner will ask you, this is important there. I'll just write down here. It looks white because all wavelengths are emitted. Now you tell me, suppose if I draw a graph, E lambda versus lambda. This is the graph for temperature T. If I double the temperature, how will the graph look like? ये exam का question है. So first thing, if you double the temperature, lambda m into T is constant. So if your temperature is doubled, lambda m will become half. Second thing, remember just now I told you area under the curve is nothing but sigma A E T power 4. So if temperature is doubled, area becomes 16 times. And this thing E peak, this is an experimental value. E peak is proportional to T power 5. In physics, it is one of the rare formula where you have power 5. So the graph would be like this, huge, 16 times the area. And this peak will be 32 times bigger.
Sir,
So if
if
this
I
is, हाँ
sir, if I heat like blue निकलने के बाद भी तो eventually ऐसी radiation निकलेगी कि दिखेगी नहीं.
X-rays will start getting.
So like
You'll
it
start
will.
getting X-rays, ultraviolet, and all that stuff. You can't see them, but they're there.
So will I see like pura dark?
Everything will become dark. You can't see.
Okay.
The room actually becomes dark suddenly for you. But if you put a detector inside, it will just go mad. It will just show a lot of intensity.
Mm-hmm.
Getting this thing? So here area becomes, so area of T by area of 2T will be how much? 1 by 16. E peak of T by E peak of 2T will be 1 by 32. So lambda m for T by lambda m for 2T will become half, 2. Take it out. Area becomes 16 times, peak value becomes 32 times, and that lambda m shifts by half. So this is Wien's displacement law. So we'll do some problems on this. Take a break, come back by 7:03. Any doubts so far? Please ask me. Anything that you're not convinced, not clear?
So
Arjun.
in question 19, can you just go to that question?
Yeah, I'll go. 1 sec. 19. Bolo.
So in this, how do you know what the ratio of power going out and getting reflected is? Like, how do you know?
There is no reflection. E is equal to 1. Everything gets absorbed. Whatever falls on the surface will get absorbed.
Acha, okay. Okay.
E1 है ना reflection का यहाँ पे we are not talking about any reflection.
Okay, fine. Got it. Thank you.
Sir,
हाँ Anusha.
could you move to the last page of the 19th question once?
19 का ये
नहीं सर, इससे भी पहले. हाँ. Yeah, thank you, sir.
ठीक है? Anyone else? Anything else? Chalo, I'll be back in 5-6 minutes. Yeah. Comes on, everyone. Let's start off. Let's start off with a question. So, what was the last question? 21. So there, E lambda versus lambda graph is given. So arrange N1, N2, N3 in ascending order. So there are three graphs of equal area, A1, A2, A3, and the number of photons emitted are N1, N2, N3. You're getting? Meaning, example, numbers would be something like this. Let's say this is like 100 to 101. This is 200 to 201. This is like 300 to 301. So you have taken equal amounts of area. So find the number of photons. Others, do keep your cams on. What is the catch here? He said area is same. Means what? The energy emitted is same. So area, which is E lambda, D lambda, you are measuring, let's say A1 to lambda 2. This gives you energy emitted per second. But what is energy emitted per second? This is nothing but number of photons per second into energy of each photon. So this is nothing but area is number of photons per second and energy of photon is hc by lambda. So if you see, this is constant, area is constant for all. H is constant, C is constant. Therefore, the number of protons is proportional to lambda. Meaning logically, so see, think of like this. You have 1 lakh rupees. Let's say you have 1,000 rupees. I also have 1,000 rupees. But you have all 1 rupee coins. I have all 2 rupee coins. Who has more number of coins? The 1 rupee guy, right? Even though both have same energy, because your energy per photon is less, you get more photons. So higher the wavelength, lesser the energy. Therefore, you should have more photons. Does it make sense? That's a more logical explanation. Like higher the lambda, lesser the energy of the photon. Therefore, you should have more photons for the total energy to be same. Therefore, we need more photons to get same amount of energy. So whoever has more wavelength, who has more wavelength? 3, isn't it? So N3 is greater than N2, greater than N1. Clear, everyone? Easy? Everyone got this? Let's see one more. Let's get this. Two bodies A and B have thermal emissivity, so E ka value is given 0.01, 0.81. Outer surface of the two bodies are same. Two bodies emit radiant power. Try this. So questions on Wien's displacement law, right? The main thing is the graph. T and 2T ka graph. That's the most important one. Questions are little less. Get this one. Read the question. Take a minute to understand. And he's saying the difference between wavelength A and B is 1 micrometer. Mu is micro 10 to minus 6. Answers are given. Try. I'll give you 2 minutes. Give it a try. Then I'll show you how to do. He's saying two bodies A and B have thermal emissivity, right? The outer surface of the two bodies are same. Meaning lambda A TA is equal to lambda B TB. That's your first thing. Because the outer surface are same, the constant, whatever is a constant should be same. Agreed? Then he's saying the wavelength lambda B corresponds to the maximum spectral radiation from B shifted by this. Second thing, you're saying they're emitting same power. So dq by dt, which is sigma area EA TA power 4 should be equal to sigma area EB TB power 4. So this is 0.01 TA power 4 is 0.81 TB power 4. So TA is 3 TB. So TB will be 5802 by 3. That is 934 Kelvin. TB aa gaya. And he's also saying the difference between the wavelengths. Now, which wavelength will be more, A or B? Whoever has less temperature will have more wavelength. So that means lambda B should be equal to lambda A plus 1 micrometer. And from here, we also know this ratio now. So lambda A is lambda B by 3. And lambda B is lambda A plus 1 micrometer. You want to find lambda B, na? So substitute here. So lambda B three by 2 micrometer. Check it out. How do you get 1939, right? 58 by 3 is 19, right? 19 sevens are, so 57, 102. Yeah, approximately 1934. Check it out, almost there. Clear with the steps? First thing, it is there in the question only. Power is same. Second thing, he said they're made of same surfaces outside, so this is constant. And then he said difference in wavelength is given. So finish it off. You have all the data.
तो वो surface से आपने वो कैसे लिखा?
Which one? He's saying the outer surface of the bodies are same. Where does radiation happen from? Surface.
बस ये बोला ना बस.
He said the outer surface of the two bodies are same.
Hmm.
So that depends on the surface only, right? So radiation happens because of the surface, no? Clear with this? There, that's about radiation. The third part is convection. Now, this technically is removed from the portion in mains, but advanced may be here. So we will do few problems on that just in case, because it is there in boards, HSC boards. It is there in bits. Mains mein nahi hai, but advanced mein hai. So the next thing is convection. So what happens in convection? Heat transfer is due to transfer of material. Example. Let's say you have a vessel here. And you're heating this with a heater. So first thing what will happen, heat will flow from the bottom of the vessel to the upper part through conduction. So once the water reaches, the heat reaches here, the water becomes warm, the density decreases, and the water starts going up. As it starts going up, it cools down. As it cools down, density increases and sinks. And this is how the heat continues to flow. So if you see in this thing, right, the material is actually transferring to send heat from one place to another. If you see on Earth, all these rains, monsoons, and everything come because of this only, convection. If you see now, on Earth, this is what happens on the Earth. As you go towards the poles and the equator, at the equator, right, it is pretty hot. You get a lot of sun rays, it becomes pretty hot. So it creates a low pressure region. At poles, it's pretty cold. The air is denser, so this creates high pressure region. And we know air always flows from high pressure to low pressure. So the winds are supposed to blow from poles to the equator like this. But because of the Earth rotation, how is the Earth rotating? Earth is rotating from west to east. So these winds actually, so for you on the Earth's surface, it looks like the winds are blowing this way. In school, you studied this thing as Coriolis force. Getting it? So on Earth, the winds are actually flowing like this. That is the reason, if you observe, in India, right, whenever you get a cyclone, you must have heard this thing. The Bay of Bengal, there's a cyclone today. The cyclone is hitting Chennai. The cyclone is hitting Andhra, Orissa. But rarely you will hear a statement that there's a cyclone in Bay of, Arabian Sea and it is coming towards Mumbai. It does happen, but it's like pretty rare. Reason, socho na, if the Earth is going to the west to east, what is happening? If you get a cyclone here, cyclone is there only. The India is going towards the cyclone. The earth is rotating towards it. So when a cyclone happens in Arabian Sea, it goes towards Dubai. That's why you won't get cyclones on this. It's very difficult to get a cyclone in Arabian. You can get a cyclone, but it won't hit the coastline that easily. That's why we see in US also now, all the cyclones that happen in US, if you see, they're on the west coast. On the east coast, you don't get that many cyclones because they go into Pacific Ocean. Getting it? Now, something interesting happens. So from this logic, so if you take India here, the winds are supposed to blow this way. But during monsoons, tell me one thing, rain start from where? They start from Kerala.
So Kanyakumari.
They start from Kerala, Kanyakumari from the border, and then they go to Karnataka, then they come to Mumbai, isn't it? Means for some reason, the winds have taken a turn. Isn't it? What do you think happened? Why did the winds take a turn? This is the whole point of Indian trades with Africa. Indian traders, right? They used to make a lot of money because of this. These people know about monsoons actually. So what they used to do now, during a normal season, India may, right? Let's say during winters or something, December, November, they used to get all the goods and they used to travel this way. The winds used to help them, so they used to travel to South Africa, African countries and everything. After selling everything there, they buy whatever they want from Africa and they used to wait for summers. During summers, what happens? Thar Desert becomes very hot. Isn't it? When it becomes very hot, it creates a very low pressure region. The wind goes up, it creates a very low pressure region. इसीलिए सोचो ना, monsoon comes always after summer. Just before monsoons, the heat reaches peak. It becomes pretty damn hot in May. Right? Those are called trade winds. Getting it? It becomes very hot in May, and the winds, right, because of this low pressure region, they start getting attracted towards the desert. The winds take a turn. So these traders wait for the monsoons and then they start back to India. Using these winds, they come back to India again. So every 6 months, they're traveling to and fro. So these winds, right, then they start entering India from bottom, getting all the moisture from this sea. You start getting rains. And as the monsoons are entering India, right, as this, October, November, December starts approaching, it starts becoming cold. Here we have a Gobi Desert near the Himalayas. That is above the Himalayas. It gets pretty cold. When you get very cold, what will happen? Density becomes high, you get a high pressure region. The monsoons are pushed back. It's called retreating monsoons. Cycle is completed. Again, the winds go back to normal, and then again the monsoons start. This complete thing is based on convection. Thar Desert is not small record. Rajasthan, वो सब desert छोटा नहीं है वो. So the point is, if this desert is not there, there would be no rainfall. Mumbai would be a desert. The whole reason why we're getting the cyclones is that particular geography of India like that. So it kind of works like that. So next time you think about monsoons, think about convection. That's how you can explain geography with physics. And that is what I did in my first class. I told you, right? What is the first class that I taught you? The first class I taught is geography. We'll talk about that some other day. It's for 8th standard students. They said JE Foundation. I went to teach and they told me how to teach geography. I said, what kind of JE Foundation is this? This is in 2006. Chennai mein. They don't know what is JE Foundation. They thought foundation matlab 8th people ko teach 9th, 9th people ko teach 10th. Can you guess what did I teach the second topic? History. By then I got pissed off. I told them, bloody, what kind of topics are you guys giving me? I told them, see, you have to give me either physics, chemistry or math. JE matlab ye hota hai. History, geography sab nahi hai. And I taught them history because already bol diya na. I taught them World War I, World War II, projectile motion weapons. Pura projectile motions I taught them using, projectile and all that stuff. And many kids so enjoyed it. मतलब उनको idea नहीं history मतलब क्या होता है. I was teaching them anything. Now see, so convection is very difficult to study. it depends on a lot of factors. So we study a very special case, force convection. Basically, this is your Newton's law of cooling. This is like, example, anytime when you drink, hot tea or hot coffee, what you do, you blow air, right? That's a forced convection. So if you're blowing wind, the wind blows to cool it down. This is forced convection. You're forcing the system to cool down. So what is Newton's law of cooling? So Newton's law of cooling says the rate of change of temperature is proportional to temperature difference between the body and the surrounding. So what it simply means is rate of change of temperature of the body with respect to time is proportional to difference in temperature minus B into TB minus TS. B is a constant, which depends on a lot of variables. Nature of material, surroundings, shape. That is the reason it is very difficult to study convection. So simply what it means is the more the temperature difference, the faster you'll cool down. So if you have a body here, this is TB and this is TS. That's it. So Newton's rate of cooling is simply the more the temperature difference, the faster you cool down. So when I was in school, I think 5th or 6th standard types, 4th standard, I guess. So during winters, it gets to get very cold, and garme heater and all was not there. So what mom used to do, she used to put this vessel on the stove and used to boil water, something like vessel, whatever. Now what I used to do, because mom is anyway boiling water, so I used to take brush aram se for 15-20 minutes. Mera concept ye tha, I'll brush for 15 minutes, so water will boil for more time, I'll get more hot water. After 1 or 2 days, mom realized this guy is doing all dance and drama, ye gas waste ho raha hai. Because after boiling for me, she has to boil the water for my sister, for my dad, and so on. Those stove, one she's cooking and one she's boiling water. So my mom told me clearly, I will boil the water for 10 minutes. After that, I'll put it down. You will bath with that, you will dance with that, you die. But 10 minutes only, she'll boil and keep it down. Ho gaya. Then one day what happened? Kuch to hua, I didn't do my brush. She boiled the water and kept it down. I said, tera water niche le lo. Now I was in a dilemma. This happened multiple times as usual. So now I had 2 options with me. Option 1, so let's say this water is there. Let's say 10 liters of water at 80 degrees. Option 1, keep the water as it is, do my brush for 5 minutes and then mix the water. Or mix the water with another 10 liters and then do my brush. Which is a better option? Did you get the question? I have 10 liters of 80-degree water. Now I have to wait for 5 minutes. Brush karne til 5 minutes lagega. I have 2 options with me. Leave the water as it is. After 5 minutes, then mix. Second option, first mix and then wait for 5 minutes. Got my question? Which was a better option?
The second one.
Second one. Why? In the first case, if I leave it here, this will go from 80 to 70. you're losing temperature at a higher rate, na? Difference zyada hai. But in the second case, when you mix the water 80, this temperature will become 50 degrees. Since the temperature difference is less, you will lose less heat, isn't it? Got the catch? Lesser the temperature difference, you will lose less heat. Clear? So this is something I realized after 2 to 3 attempts. So that time I didn't know Newton's law of cooling, but yeah. Clear with this? Now you have heaters and all, so we don't do all this kind of stuff. So what kind of questions I can frame on you? See. Let's say temperature of the body is 2 T naught and surrounding temperature is T naught. Assume Newton's law of cooling. That is rate of change of temperature TB by dt is minus B TB minus TS. So see here what happens. As the body starts cooling down, the difference becomes smaller. If the difference becomes smaller, you will lose less temperature. Find the temperature of the body as function of time t. Let's get this. Straightforward integration. dTB by dt is minus B TB minus T naught. Integrate. Initial temperature body is 2 T naught to TB 0 to T. This will be ln TB minus T naught minus BT. This is TB minus T naught by T naught minus BT. So we get temperature of the body will be T naught into 1 plus e power minus BT. So if you try to plot this graph, temperature of the body versus time. So initially you start from 2 T naught, you end up at T naught. Takes infinite time to cool down actually, theoretically. It's an exponential graph. Sometimes they'll also ask you in terms of ln mein graph. Ln TB versus time. Then the graph would be something like a line with a negative slope. Because if you see that ln TB minus TT will be minus BT plus ln T naught. This is a ln delta TB, temperature difference. So if you take a ln graph, it is a straight line. If you take a T versus time graph, it will be an exponential decay function. Clear? Simple max. All got this? Next one. This is important. I will teach you two methods. One is for advanced purpose. One is boards may what they do. Let's say we have a body. Cools from 80 degrees to 70 degrees in 10 minutes. Okay. How much time does it take to cool from 70 degrees to 60 degrees? If the temperature of the surrounding is, let's say, 30 degrees, assume Newton's law of cooling. Let's get this. So 80 to 70 took you 10 minutes. 70 to 60 will take how much time? We will do this in two methods. One is proper integration, and one I'll teach you an average method, which they do in boards. Others do. Keep your cams on. We'll be wrapping up the chapter today. Next class, we'll start with fluid mechanics. Technically, though, we finished it. Mains portion, this is not there, but advancement there, so we will do this one. Again, do finish off your PACE booklet or whatever your classes ka booklet you're doing. I'm telling you again, don't try to do 10 books. Whatever your classes ka material is there, finish it off end to end. By November first week, after Diwali gets over, we'll be wrapping up a portion before Diwali. So after Diwali gets over, by November 10th or 15th maximum, you should be saying like, sir, every chapter ka booklet I have done or HCV I have done. One book should have been done properly. You're getting it. Once that is done, meaning you're sure that sub chapter at least basics you have an idea, because JEE mains they're not going to go in depth. What they want is coverage. Getting it? And once that is done, November we will start doing PYQs, and there are almost 2,500 PYQs in physics. That will take a month to 30 to 40 days. We'll finish off that entire thing, and then we'll start writing tests. I'll be taking speed tests. We'll having revision classes. We'll have a lot of things. Getting it? So the primary thing is you should finish your material. Do one material. Why bolna? Don't run behind that Cengage, that book, this book. You want to do Cengage, do it, but finish it off. Problem why hai? That book has 400 questions per chapter. You can't complete. So choose one book and finish it off. How to do this thing? So 80 to 70 degrees took you 10 minutes. 70 to 60, you want time. Surrounding temperature is 30 degrees. So dTB by dt is minus b, TB minus TS. Integrate. So this will be from T initial to T final. Here, remember, TS is constant, TB is variable. So this will be ln TB minus TS. So that will be T final minus T surrounding by T initial by T surrounding is minus BT. This is your general formula. 10 plus ln 8 by 7, 7. अच्छा number नहीं आएगा निकाल, lns में आएगा. So here in the first case, ln T final is 70 minus 30 by 80 minus 30 is equal to minus B into 10 minutes. This is when you go from 80 to 70. when you go from 70 to 60, ln 60 minus 30 by 70 minus 30 is minus b into time. Divide them. Then you end up with equation 2 by 1. You will get t by 10. This will be ln 3 by 4 by ln 4 by 5. So there, time will be ln 4 by 3 by ln 5 by 4. That's your answer. This is the right way of doing it properly. 7 minutes kya? Arey God, shouldn't it take more than 10 minutes? Logically socho. It takes more time, right? Itna to guess kar sakte. Now, how much is this is a different story. I hope you guys know how to find ln. You can figure it out. Okay? But now, if this comes in bits, mains mein they might not ask, or boards mein how to do the same question, alternate method. We use average method. So what we do in this, we can choose average temperature of the body while solving. Means, you know, what you're doing in the graph, technically speaking, temperature of the body minus time, the graph kind of looks like this. So if you take a very small temperature difference, you can assume this is almost a linear line. We assume function is linear for small temperature time, for small temperature change, which is kind of valid. You get an error in second decimal. Small temperature difference. So what we do in this method, you're going from 80 to 70. So we take body ka average is 75. Means you're assuming you're losing heat at a rate at 75 degrees pe. Then 70 to 60, you take the average body of the temperature is 65. And this is what the formula we use. So dTb by dt is minus b, body ka average temperature. So we are assuming you're losing heat at a constant rate, Ts. So first case mein it is 70 minus 80 by time is 10 minutes. Minus b, average is 75 minus 30. Second case mein it is 60 minus 70 by time minus b, average is 65 minus 30. Divide equation 1 by 2. You end up with t by 10 is equal to 35 by 45. Yeah, must have somewhere 45 by 35. So that would be around 97.57 by 7. It's approximately 7120 72 8 minutes approximately, something like this. Clear this? So how do you know you have to use logs or the average method? Look at the options. Options, if ln is not there, then use ln, then use this regular method. HSC, this is what you have to do. HSC, it is there. Have a look at this. So average method is little convenient. Ln, gain, integration, kuch bhi nahi aayega. Directly you can put and finish it off. But there is a problem with this method. It doesn't work. So this method fails if the temperature difference is too big. It won't be linear anymore. Maybe 5-10 degrees is fine. But if your temperature difference is 40-50 degrees, it's messed up. Second thing, if temperature of the body is pretty close to surrounding, surrounding a temperature is 30. If temperature of the body is 40 degrees, this will give a lot of errors, because if you see this graph becomes almost flattish. If temperature of body is close to surrounding. So then in that case, we have to use the Lorne method only. Clear with this average method? Let's see one question on average method. Any doubts on this, please ask. Turning the page. Clear na, Aryan, Lakshika, Ali? Same question. Now you guys try. Suppose 80 to 70 degrees, it takes 10 minutes. 70 to some temperature, if I give another 10 minutes, what will be the temperature? Temperature surrounding is 30 degrees. Now I'm asking reverse. Use average method. 80 to 70 took 10 minutes. If I give another 10 minutes, temperature kitna hoga? It won't be 60, na? It should be more than 60. Get this? So I can say 80 to 70, 70 to 60, find time, or I can say time is same, find t. You can play both the ways. These are the two models you have in boards and mains. These are the two models that used to be there. If they ask you in terms of Lorne, it becomes an advanced question. We will do that also one. The numbers. $62. So using average method, 80 to 70, the body ka average temperature, you take it as 75. When you go from 70 to T, the body ka average temperature, you take 70 plus T by 2. Now use the formula dTB by dt is minus B. T body average minus T surrounding. So for the first one, it will be like 10 degrees, time is 10 minutes, minus B averages 75 minus 30. Second one, temperature difference is 70 minus T, time is also 10 minutes, minus B, this is 70 plus T by 2 minus 30. Divide them, that would be let's get B ka value from here better. So B will be minus 1 by 45. Take this B and dump it in this. This is 70 minus T by 10 minus 1 by 45. This is 35 plus T by 2 minus 30. 70 minus 2 by 10 minus 1 by 45. That is 5 plus T by 2. 70 minus 2 by 10 minus 1 by 90. 10 plus t. Cross multiply. 9 sevens. 670 minus 90 is minus 10 minus t. We get t is equal to 670 by 8. 680 by 8. How much is this? 4 twos are. I messed up somewhere, no?
बी में माइनस
तो बी में माइनस साइन है तो फिर
तो
सब्स्टिट्यूट करते वक्त प्लस हो जाएगा।
Yeah, minus sign है ना? You're right. That would be 630 minus 90 is 10 plus t. So that guy would be 620 is 10t. T is 62 degrees. ठीक है? Clear with the average method? Easy. Any doubts on this? Same question. Let's say you're going from 80 to 70 in 10 minutes. And you're going from 70 to, let's say, 35. I want you to find the time. Whereas temperature of the surrounding is 30 degrees. Now what will you do? Now be careful here. We can't use average method. Ln में आएगा. So here average method will give an error because the temperature is too close. Temperature difference भी बड़ा था, and temperature of the final temperature of the body is close to surrounding. Basically, point क्या है ना? If you get closer and closer to the surrounding temperature, it takes infinite time. So the graph is almost like this. What you're doing is you're taking these 2 points and saying this is a line. That doesn't make sense anymore, isn't it? Finish it off. How will you do this thing? Average method we can't use. You just have to get back to the ln thing. You have to go back to this one again. Ln t final minus ts by ln t initial minus ts. So t final is 70 minus 30 by 80 minus 30 is minus b into 10. Ln 35 minus 30. Now, for example, see, if I said this is 30 degrees, you would have got ln 0, no? Suddenly it becomes undefined. This guy would be 70 minus 30. t and minus b into time. Divide them. Equation 2 by 1, you end up with time by 10 is equal to ln, that is 5 by 40, the 1 by 8 by ln 44 by 5. Clear? That's your answer. So we get t is equal to 10 ln 8 by ln 5 by 4. So be careful with this Newton's law of cooling. There are two methods, average method and this thing. Most of them average works, but in certain rare cases like this will be proper advanced questions. Generally, even in bits, mains mein nahi hai, boards, always average method works. If at all they ask you something, it's an advanced question only. And the best way is you'll get a hint. Options dekh ke idea aa jayega. Matlab temperatures one, options mein there'll be lawns. The moment you see a lawn, that's a big red flag. Like, yaar, why the hell do you need to give lawn for average method? Clear with this? With that, we are done with heat transfer. So we have completed entire heat and thermodynamics. The entire thing is a big chunk. So do start solving your pace booklet, your classes ka jo bhi material, try to finish it off. I'll send you one sheet on the entire stuff so you can do that. And next class when we catch up on today's what, Friday, we'll start off with the fluid mechanics. The fluid mechanics is again 4 parts, properties of matter actually. Fluid mechanics and statics. It looks like laws of motion. Then we have viscosity, surface tension, and elasticity. So that one full chunk, we'll wrap it up. And then we'll go for oscillations. Okay, so this will wrap up for the day. And like I said last time, there is a paper, I think still online till tomorrow. It's on full mechanics. It's an optional paper. So someone wants to give, you can give it. Okay, so this is a wrap up for the day. So any doubts, anything, you can stay back and ask. Also free to leave. So first make sure to go through the entire notes once.